All right, guys. So let's discuss question number 2. So we have a hypothetical 2D lidar device, right? And it says that it has a field of view ranging from -45 to +45, right? And these are basically the range data that you're getting in one scan, right? So what this really looks like is you have your, give me a sec. Yeah, you have your x-axis and your y-axis, right? And you have a lidar that is scanning with +45 and -45 angle, right? So its field of view looks something like this, right? +45 and -45. So it's scanning a region that looks something like this, right? And you can see that within this region, we have 1, 2, 3, 4, 5, 6, 7. We have 7 readings, right? So something like this: 1, 2, 3. 1, 2, 3, 4, 5, 6. Okay, sorry, I screwed that up. Yeah, that's 1, 2, 3, 4, 5, 6, 7. So we are getting range readings from these 7 discrete points, right? So by the way, each of these angles will be equal. I've like my diagram might not be the most accurate, but like you guys get the idea, right? So each of these angles will represent 15 degrees, right? Because you have a field of view of 90, right? And you have these, you have to divide it into 7, right? And that would roughly put each of these angles, yeah, that would put each of these angles at 15, right? Yeah. So the question is, can we take this range information and convert it into Cartesian form, right? So let me just copy paste this. Actually, the answers, right? So what I'm going to do is I'm going to first make an array of all those ranges that I've given you guys, right? Next, what I'm going to do is I'm going to use MATLAB's line space function, right? Or linspace if you want to, like, yeah. And what this linspace function does is it divides a initial point and a end point by this number that you give it, right? So for example, if I say linspace 0, 10, and I want it equally divided into 5 points, right? It will give me an array like this, right? So it will take into account the initial point and the end point, right? And give you 5 different points, right? That equally divides this range, right? So what I'm doing is I'm giving it -45 to 45 and saying 7, right? Divide that into 7, and what I'll get is each of these angles, right? Because the first angle is -15. The next angle is, sorry, first angle here is 15, then I should get 30, and then I should get 45, right? Here I should get -15, -30, and -45, right? For me to convert these range values into my Cartesian form, right? So if I actually do it this way, you can see that I get the angles that I want, right? So I'm dividing the range -45 to +45 into 7 different values. Right, so now that I have the ranges and I have the angles, it's just a matter of multiplying each of these ranges into the costs of these angles to get the x values, and to get the y values, multiplying these ranges with the sine value of these angles, right? So that's what I've done here, right? So you probably can see that I've used a dot and then multiplication, which what that does is it does element wise multiplication instead of matrix multiplication, right? Because we have two arrays here. We have one array here of the ranges, and then we have another array of the angles. And if I just use the multiplication sign, what I'll be doing is I'll be doing a matrix multiplication of two different arrays, right? And if you multiply a single array this way with an array this way, what you'll get is a matrix. And that's not what we want. We want each of these values to be multiplied by each of the values in this angle array. So we use this dot multiplication. It's called element-wise multiplication, right? Instead of matrix multiplication. Also, there's this comment that I put here that you can use the pol2cart function, right? So instead of actually multiplying each of these ranges to the cos and sine values of these angles, there's also a MATLAB function called pol2cart, right? So if I say help pol2cart, what I get is how to use this function. What it does is it transforms polar coordinates into Cartesian coordinates. Essentially, it's doing the same thing as this multiplication, but you can, if you want, use this function straight away and just give the ranges and the angles, and it will give you the Cartesian coordinates out straight away, right? So you have that option as well. Anyway, so now we have the x values and the y values, right? Let's just plot those x values and y values out. I'm actually using the scatter function because what we are getting are discrete set of points, right? Actually, even in the previous question 1, I think it's better if you used scatter because you're getting a set of points, right? I'll actually run that again. So yeah, that's actually what the laser scan looks like in the previous question. It's better to use scatter because what we are getting are a set of discrete points. Okay, anyway, back to question 2. If I run this is what your laser scan in question number 2 looks like, right? A set of points. Yeah, so that is the end of question 2. Now what you can do is look at question 3. So in question 3, there's you don't really need to use MATLAB or anything. I just want you guys to look at these two images and kind of figure out what sort of transformation has taken place, right? So I'll give you guys a few minutes to kind of look at question 3 and we'll discuss it.